My name is Ashish Mahabal, and we'll continue to look at R today. Today we'll be looking at classes in R. And as we know, R has come from S, and the nomenclature that was used in S has continued with R classes. So S3 and S4 are the two main classes that are used in R. Google has a style guide on how to use R classes, and they recommend that S3 is much better than S4, though S4 ones are more rigorous, and we'll be seeing more details about that. But one important thing that is said by everybody, irrespective of whether they say S3 are better than S4 or S4 are better than S3, is that you should try not to mix the two classes, because S4 are definitely more rigorous and S3 are more pardoning, but again, if you're not expecting some kind of behavior that comes about in S4, then S3 can lead you to grief. So there are two more types of classes. The base class, where typically C is used, and reference classes, where in-place modification is possible. We may not be seeing much more details of that, but the URL that is given here will provide you more details if you are interested in something like that. So let's start with S3 classes. They have existed for a long time. The third version of S is where they came about. Essentially, what an S3 class has is a list and some methods and inheritance that can be done with that. And then it's a bit more generic and casual, very unlike what a class would be in C++. In particular, there's no error checking. So if you have certain variables that exist in your class and you make a typo and during some assignment provide a different variable name, it'll happily take that and will not even tell you that that is not what you had first given, etc. So you have to be sure that that is what you'll be wanting. Let's try to define an S3 class. Let's say that we have a few galaxies and we want to define a class called galaxy. So here you see that we have a variable g, and we make it a vector by assigning a list to it. We provide some named variables, name equal to, say, NGC4261, array such and such, declination such and such. Array and declination are the two variables that tell you the position of the object, galaxy in this case, on the sky, just like latitude and longitude. And then there is a certain magnitude. And then once you have defined this variable called g, then you can say that class of g is galaxy. And just doing these two things together defines for you that class. Now you can go ahead and check the attributes of the class. Since g is an example, you can say attributes of g, and then it will immediately tells you what are the names available with g. And those are, in this case, name, array, declination, and mag. And then it will go ahead and tell you that the class is galaxy, that is, belongs to the class galaxy. And then you can print info about that particular object. So if you were to simply say g, which is equivalent to, say, print g, then it will tell you that the name that is available is NGC4261, the array value is given there, the declination value is given there, and the magnitude is given there, and that the attribute of the class is galaxy. So one of the most interesting thing, what we alluded to in an earlier talk, is how we can change some of the default methods. So in this case, if we wanted to change the print method, then we can do that fairly easily. Here we saw that if you simply say print g or g, you get the default print values. But that's not what we want to print, say. Suppose we wanted to take a look at where the galaxy is, try to get a sky map of it. One can easily do that in R using how the methods can be overloaded or modified for this specific case. In particular, let's look at one method called browse URL, which takes as an argument URL and simply goes to that particular URL. It also, of course, like in other cases, takes many different arguments, but in this case, we'll just worry about the single argument called the URL. So let's define a new print class for our galaxy to display an image. So the definition of that function is given on the slide. So if you say print.galaxy, that is what our method is going to be print is the default name, and .galaxy tells us that it is for the class Galaxy that we are defining that. And the function takes as an argument just the object for which we are going to be talking about, in this case, let's say G. And then we define within the function a base URL, which can be the URL that we want to go to. And the URL is going to depend on two variables in this case, the array and declination for the galaxy. So then we cat the name of the galaxy, which will get printed on the command on the output. And then we paste the base URL, the array with its value, the dec with its value. And the last command is also, the last argument is also very important, separator without any spaces, because the default is a space. So when you paste those together and assign that to GURL, then you can simply call browse URL with that argument GURL. And then your print function has been defined for that class. Now, if you look at methods of this particular class, Galaxy, then you'll find that you are told that it does have one method called print.galaxy. And now if you go ahead and say G or print of G, you will see that the cat command gives you ngc4261 on the output, but at the same time it opens a browser, and in the browser you in fact see the position in sky at that particular array and dec that you have said that the object G belongs to. And that is what you see on the right hand side. This is a slow image of ngc4261. So again, this is an S3 class that we have defined and a specific print method with it. If we had misspelled any of the attribute names, for instance in declination we had spelled it with D lowercase or RA lowercase RA, then the program would have accepted that, would not have given us any error, but just that there wouldn't have been any useful output. So that is one thing that you have to remember. Now S4 objects are more rigorous. Here the way they are defined is with a slightly varying, slightly different syntax. You say set class. Here we are using the class name to be Galaxy S4, and then you have a representation for it. Again, we'll use the same variable names, but here we tell what types those variables are. Remember earlier when we used with S3, when we defined the class, we didn't have to say anything of that kind. We just went ahead and defined the list, whatever that list contained. But here we have to say that the name is of type character and the other three variables are of type numeric. And that's again all for the definition. Then you can say that GS4 and assign to it a new Galaxy S4, and then you give it the data through the names and variables there. So name equal to ngc4261, same as before, right? And then that defines for you an S4 type of class. In this case, GS4 is an example. So now if you go ahead and say GS4, then it will tell you that it's an object of class Galaxy S4. And now what it uses are what are called slots. So it says that it has 4 slots. One is the name, and array, declination, and magnitude. And these slots in S4 are accessible using the @ character. Remember in S3 we had the $ character. So you could have said G $name and got back ngc4261. To do that with S4 classes, what you have to do is GS4 @name, and you'll get the same information. There are these minor differences, but the main difference, of course, is the error checking involved and the rigorousness with which the class itself is defined. So what is print after all, which we have managed to overload in this fashion? So it completely depends on the context in which it is being used. So if you were to simply say print at the R prompt, you will be told that it is a function which takes X as an argument and ... indicating that there are many more arguments. And all that is happening is the use method print is being called. And so when you say print Galaxy without any arguments just by itself, it tells you how that particular function is defined. That is another very useful thing in R. If there is a function and if you simply give the function name, it provides for you the body of the function. So you can take a look at any function that R is using at any time just by typing the name of that function. So here we see the definition of our function print Galaxy. So there are many different prints available, and all you have to do is say methods print on the R prompt, and you will get to know that there are over 100 or 200 prints that are accessible to you. The ones with stars are typically in other namespaces, so you may have to do something specific to get access to those. But So take a look at the, let's see, print.by, which is the 18th one, the last one in this row, or print.aspell, which is 13th here. So the aspell comes with an asterisk, which tells you that if you were to simply say print.aspell, you won't get immediate access to it, but you'll have to do something different. Whereas print.by is without an asterisk, so you can simply say print.by and you'll get access to that. But aspell, though print.aspell, you don't get access to that directly, you can get access to aspell itself directly. What that tells you is that R even has things like spell checks just on the prompt. In the command line, you can simply take a file and check for its spelling fairly easily. There are also ways of using R through Python. And you can simply, you get a package called rpy2. There used to be rpy before, and it's rpy2. And you can load it within Python. So the way to do it in Python, of course, is using the import command. So if you say import rpy2.robjects as robjects, then it becomes accessible to you. And here, a simple example of that has been shown. So x equal to robjects int vector range 10 gives you the first 10 numbers there. And r.rnorm. rnorm is the familiar R function that we have seen many times. We are simply taking 10 numbers out of that and calling x11 to plot it later on. So this functionality of using R through Python is also possible, and with NumPy you can use it in a very effective manner. I don't know if some of you noticed, but when we printed information about the various variables in our galaxy, the input to array was given to 5 decimal places, but when we printed it out, then it was only to 4 decimal places. So was the 5th decimal place lost? Is R not precise? That's certainly not so, because if you see slot of array here, you get only 4 decimal places. But so where did the last digit vanish? So this is something about the precision in R. The default precision is at a certain level, but you can also instruct R to use a slightly different precision. So you could say that I want to use 10 digits, and you can say that by saying options digits equal to 10. And that's again a suggestion. You can go up to 22. So when does it get used and when does it not get used? So look at the next example. Here we are saying that there is a sprint of pi, and we want it to 100 decimal places. And the output is shown there. It becomes inaccurate after about 15 decimal places. But does that mean again that R is not precise after 15 decimal places? No. Again there, it depends on whether you are using large numbers or you are using very small numbers. So the precision can go arbitrarily small, well, not arbitrarily small, but up to 308, e to the power 308, which is fairly small. And that you can see by seeing what the limit of double is, the machine double that it is using. And then you can use additional tools within R to go to quite high precision. But then again, when it is that you may run into problems, and that is what is shown in the next example. So if you are trying to compare very small numbers versus significant digits, then some things that you have to keep in mind are that if the differences are very small, so that the numbers start looking constant and they're not close to 0, then you can be in trouble. So the first example here shows that we are assigning to x1 50 numbers with a mean of 1 and a standard deviation that is very small, 1 e to the power minus 15. Right? And y1 is where we use something where we say that, again, we want 50 numbers, and in this case, the mean is slightly different with the same standard deviation. So if you notice, then 1 and just a small delta. Now these two numbers are very close to each other and not close to 0. So their comparison is going to look as if it is a series of constants. And that is going to throw an error for you because all the numbers seem constant. But in the second example, what we do is that we assign to x2 numbers that have a mean of 0, and again a very small standard deviation. And to the second vector, we assign numbers that are very close to 0 mean, but not 0, and the same standard deviation. In this case, if you try to compare them, you'll be fine. So again, it depends very much on what kind of numbers you are trying to compare and what kind of precision that you want with them. R will allow you to use them in a proper fashion. Next time we'll be seeing ggplot and some advanced plotting.